Okay, dear learners and students, I welcome you all in this class. So in this class, we will discuss about metals and non-metals and the theory portion of this chapter. And this is your chapter third of NCERT CBSE class 10. And I'll discuss about the most important and relevant topic that will be asked in your upcoming board CBSE 2025. Okay, so without delay, let me begin. Okay, in first we'll discuss about the physical properties of metals. Usually metals are solid. They are solid in room temperature. Okay, they are what? They are solid in room temperature except mercury. So mercury is the only metal which is liquid at room temperature. Remember that mercury is only metal which is liquid at room temperature. Similarly, all metals are hard except lithium, potassium and sodium. Like lithium, sodium and potassium are, you can say, they are soft metals. Okay, they are what? Soft metals. We can consider this they as soft metals. Even all these metals, they can be cut with the knife. Okay, next one, metallic luster. Like metals have that shining property. Okay, we will call that lustrous property. That means all metal are lustrous. Next one is metals are malleable. Malleable means that metals can be beaten down into thin sheets. Okay, next one is metals are ductile. All metals can be drawn into thin wires. Okay, next, metals have high melting point. Like gallium and cesium have low melting point. Okay, they melt in the palm of hand. So you have to remember one thing out here, that is metals have high melting point. Why metals have high melting point is that किन चाहिँ मेटल्सको चाहिँ हाई मेल्टिङ पोइन्ट छ भन्दा चाहिँ नि, बिकज सी मेटल्स आर सलिड नि त. मेटल्स आर वाट? दे आर सलिड. द्याट मिन्स इफ मेटल्स आर सलिड, द्याट मिन्स फोर्स अफ इन्टरेक्सन बिट्विन टु पार्टिकल्स. सी, this is one particle, so all the particles are densely packed. That means this distance between two particles, that is, the distance is very what? Less, and the force of interaction between those two particles is very strong. So that is the case why, in order to break this bond between these two particles, we need high amount of energy. That is the reason that all metals have high melting point. Okay, so in case of gallium and cesium, they have low melting points because of their own property and own chemical formation. Okay, so they melt in even a palm of the hand. So gallium and cesium are only two metals which can be melt in the palm. हातमै तपाईको के हुन सक्छ? मेल्ट हुन सक्छ. Okay, so next one, metals have high boiling point. Okay, even they have high boiling point just because of this reason. Okay, just to, in order to break this bond between two particles, they require high amount of energy to break this bond. Okay, so that is the reason why metals have high boiling point. Okay, next one is metals are good conductor of heat. They are even good conductor. Best conductors are silver and copper. So silver and copper are the best conductor, and poor conductors are lead and mercury. So you have to remember this, which are the metals, which among the following metals are poor conductor. So that is lead and mercury. So MCQ can be expected from this chapter. Okay, so metals are good conductor of electricity. That is, best conductors are silver and copper. So metals are good conductor of electricity. Likewise, which metals are good conductor of electricity? That is silver and copper. Okay, okay. Next one, metals are sonorous. That means, what is sonorous? That means metals can produce sound. Metals can what? They can produce sound when beaten. Like you have seen in the school hall or anywhere, if we hit the metal with any stick or any other metal, they produce sound, and that property of metal is called sonorous. Okay, so that means metals are what? Sonorous, or they have that property. Fine. Okay, moving on. What are the physical properties of non-metals? So in previous slide, we have discussed about the physical properties of metals. So in this slide, we will discuss about the physical properties of non-metals. So non-metals may be solid, may be liquid or gas. Okay, so all non-metals can be categorized in three state. Okay, some can be solid, some can be liquid, and some can be gases. Say for example, in solid categories, we can consider carbon is solid. Okay, sulfur is solid, phosphorus, etc. And liquid, we have considered bromine. Okay, liquid, that which one is the, so say for example, in exam, what kind of question you can expect? Which one of the following is a liquid non-metal? Okay, liquid nonmetal. So bromine is a liquid nonmetal, and gases, oxygen, hydrogen, nitrogen, etc. gases. So non-metals are soft. So in case of metals, metals are what? Hard and rigid. So but in case of non-metal, they are soft except diamond. Okay, so diamond is what? Diamond is non-metal. It is a allotropic form of carbon. Okay, diamond is what? Allotropic. Allotropic form of carbon. So except diamond, which is hardest natural substances. So which is the hardest natural substances? It is what? It is non-metal. It is an allotropic form of carbon. Remember, diamond is allotropic form of carbon. Okay, so non-metals do not have luster. So metals are lustrous, that and these non-metals are non-lustrous except this one is very important. Okay, iodine crystal. That means iodine is the only non-metal which have this lustrous property in case of non-metals. Okay, so non-metals are not malleable, non-metals are not ductile, non-metals which are solid and liquids have low melting points. Okay, so these non-metals which are solid and liquid at have what? They have low melting points. Similarly, no metals which are solid and liquids have low melting points. So remember this point. Okay, non-metals which are solids and liquids have low boiling points, which are solid and liquid. Remember this. Okay, gas, in case of gas we can expect different story, but in case of solid and liquid that are non-metals, they have what? Low boiling points and low melting points. Remember. Okay, so next one what we can expect? You can expect that non-metals are what? Bad conductor of heat. Okay, non-metals are bad conductor of electricity. And another example is graphite. Now again, this graphite is also what? It is a allotropic form of carbon. So carbon ko allotropic form, one is diamond, another one is graphite. This is hardest natural substances, and this is what? A good conductor of electricity. So this is very unique case in case of carbon. Okay, so non-metal are what? They are not sonorous. That means they cannot produce sound. Okay, so moving on. So we'll discuss about chemical properties of metals. So how metals react with oxygen? So if metals react with oxygen, they will form what? Metal oxide. Remember that. Okay, metal oxide. So metals react with oxygen to form what? Metal oxide. So when copper is heated, it's combined with oxygen to form copper oxide. So this is the copper, this is oxygen. So they combine. So here I have already balanced this chemical reaction, because two Cu plus O2 will give you what? CuO copper oxide. So here oxygen is 2, here is a 2 atom of oxygen. So here we have only one atom of oxygen. So balancing. So while writing 2 in the LHS of this equation, so I have to write 2 in front of Cu. So this is now balanced. Okay, similarly this is balanced. So when aluminum is heated, it combines with oxygen to form aluminum oxide. So this is the balanced chemical reaction. Some metal oxide are basic oxide because they react with water to form bases. Okay, so usually metal oxide are acidic. Okay, but some metal oxide are basic oxide because they react with water to form bases. Like sodium reacts with oxygen to form sodium oxide, and sodium oxide react with water to form what? Sodium hydroxide. Similarly, potassium react with oxygen to give what? Potassium oxide. And potassium oxide, when treated with, so this is slightly, you can write out here, not in the arrow. Okay, potassium oxide when treated with water, it will give what? Potassium hydroxide. Okay, it will give what? Potassium hydroxide. So some metal oxide shows both acidic and basic properties. Okay, so some metal oxide are there which show both acidic and basic property, and these type of oxide are called amphoteric oxide. So what do you mean by amphoteric oxide? Amphoteric oxide are those oxide which show both acidic and basic properties. Okay, so they can react with both acid and base. So in case of aluminum oxide, aluminum and oxygen, this valence of aluminum is 3, valence of oxygen is 2. So it will become what? Al2O3. This is what? Aluminum oxide. So aluminum oxide can what? It can combine with both oxygen and, sorry, not oxygen, it can combine with both base and acids. So to give what? To give both acidic and basic properties, to expand or to show. So this is the compound. Aluminum oxide, or you can say even zinc oxide will same kind of properties. Okay, so next here, moving on. See here, aluminum oxide react with acid to give what? Aluminum chloride plus water molecule. And similarly, this is what? This is basic. This is basic. And aluminum oxide, when react with sodium hydroxide, it will give what? Sodium aluminate plus water. So this is what? This is salt. Okay, moving on. So reactivity of different metals with oxygen is different. Okay, so different metals have different reactivity when react with oxygen. So this is very important part. So if metals like potassium, okay, metals like potassium, it reacts with oxygen, and metals like react with metals with sodium with oxygen, they react what? They react very vigorously. Okay, so you can expect one question from this section. Okay, why potassium and sodium metals are kept immersed in a kerosene well? What is the reason why these two elements are kept immersed in a kerosene well? The answer is very simple, because potassium and sodium are very reactive metals, and they can vigorously react with what? Oxygen, and they can even catch fire when kept open, or if kept in open space. Hence they are what? Stored in kerosene to prevent burning. This is very important part. So next is, if magnesium is heated, it burns with bright flame. So magnesium is a metal. If react with oxygen, so you can expect what happens when magnesium ribbon is bound in air. So it produce what? Bright flame. So if iron is heated, it glows brightly. Suppose we have iron. Iron has two valency of 2 and valency 3. Okay, so if you consider valency of iron as 2, you will call what? Ferrous oxide. Okay, ferrous oxide. So if you consider a valency of iron as 3, you will consider it as ferric oxide. You will consider it as what? Ferric oxide. So if iron combines with oxygen, then it will produce what? FeO, ferrous oxide, or you can say it will combine what? Fe2O3, it will produce what? Ferric oxide. So both of them, it will glow. Okay, it will what? It will glow. Okay, next one is, if copper is heated, it does not burn but forms a black coating of a copper oxide. Okay, so what happens if copper is treated with oxygen? If copper is treated with oxygen, it does not burn. Okay, it does not burn, but black coating of copper oxide is formed, that is CuO. That is, this is what? Which color? Black color. Okay, so if copper is treated with oxygen, then black color of copper oxide will be formed. So next, other one, silver and gold does not react to oxygen even at high temperature. That is the reason why this gold does not corrode. Corrosion of gold and silver is not possible. Why? Because they did not react with oxygen, and corrosion will occur only if the metals react with oxygen or with water molecule. Okay, so in this case, which is the metal, which are the metals, or which is the metal which is leastly affected by the corrosion? So your answer will be gold and silver. Okay, so these two are the metals which are least affected by the corrosion. Okay, so some metals like magnesium, aluminum, zinc, lead, etc. forms an oxide layer over it which prevent further oxidation. So they are called self-protecting metals. So why magnesium, aluminum, and zinc, lead, etc.? Because see, if aluminum react with oxygen, it will become Al2O3, aluminum oxide. Okay, so this is what? So this oxide will further prevent this particular element from oxidation. So what is oxidation? Oxidation is what? It is a process by which oxygen is added in the chemical compound. So this compounds of oxygen, okay, this compound of oxygen like aluminum, magnesium, zinc, lead, etc., they forms oxide layer over it which prevent further oxidation. So oxide of these elements, okay, oxide of these elements prevent the particular element from the oxidation process, and they are called what? Self-protecting metals. Okay, so moving on. So what happens when metals react with water? So metal react with water to form metal oxide or metal hydroxide and hydrogen. Suppose see, in for first case, metals is reacting in water to form what? Metal oxide. That means sodium reacting in water, it will give sodium hydroxide, plus the evolution of hydrogen gas is taking place. Similarly, potassium plus water is giving what? Potassium hydroxide plus what? Hydrogen molecule. And calcium plus water is giving what? Calcium hydroxide plus hydrogen molecule. So aluminum plus water, similarly aluminum oxide plus hydrogen molecule. And iron plus, okay, iron, in case in case of this equation, okay, in this equation, our iron balance of iron is what? 3. Okay, 3. So okay, so this is the example. The reactivity different metals with water is different. Okay, so different metals have different reactivity towards hydrogen. Just in our case, sodium and potassium react violently with cold water to form sodium hydroxide and hydrogen and catches fire. Okay, so sodium and hydrogen react very violently with cold water. Remember, water should be cold to form what? Sodium hydroxide, or you can say potassium hydroxide. In case of sodium, it will form sodium hydroxide. In case of potassium, it will form potassium hydroxide and hydrogen, and they can even catch fire. Okay, so calcium reacts less violently with water to form calcium hydroxide and water and does not catch fire. So in case of calcium, it reacts with what? It reacts with water. Okay, it reacts less violently. It does not react with water, but it is reactive, and this compound does not catch fire. Okay, so magnesium, this in case of magnesium, in case of magnesium, what happens is magnesium react with water, so it will become what? Magnesium hydroxide. And see, magnesium hydroxide, this water should be hot. Magnesium cannot react with cold water, remember that. Okay, okay, metals like aluminum, zinc and iron. Okay, metals like aluminum, zinc, like aluminum, zinc, they can only react with water, which is gas. That means water molecule or should be in vapor state. Okay, and metals like lead, copper, silver and gold does not react with water. That is the reason why this gold, silver and copper does not follow corrosion. In last slide, I have discussed about this thing to you, that copper, silver and gold does not react with even with the oxygen and even with the water. That is the reason why this gold, silver and copper does not corrode, or corrosion would not take place. Okay, so moving on. So what is the reaction of metals with this acids? Okay, acids. So if metals react with acids, then salt will be formed. Salt plus hydrogen gas will be liberated. Okay, so in our case, magnesium react with hydrochloric acid to form magnesium hydrochloride. Okay, magnesium, not hydrochloride, so sorry. If magnesium react with hydrochloric acid, then magnesium chloride will be formed. Similarly, aluminum react with hydrochloric acid, aluminum chloride is formed. Zinc react with hydrochloric acid, zinc chloride will be formed. But now one point important to note out here is that reactivity varies from metal to metal. So for the above metals and decreasing order reactive will be magnesium is reactive than aluminum, aluminum is reactive than zinc, and zinc is reactive than iron. So you know the metal reactivity series, you can discuss that in your class. Okay, so reactivity, copper, silver and gold does not react with dilute HCl. Okay, they can react with concentrated HCl. That means concentration of hydrochloric acid should be very strong. If you add water to that acid, then it will become dilute, and this copper, silver and gold does not react with. Okay, hydrogen gas is not evolved when metals react with nitric acid. So this part is very important. I am giving you a star out here. Why this part is important? Because see, hydrogen gas is not evolved when metals react with nitric acid, because it is a strong oxidizing agent, and it oxidizes the S to produce to water, and it itself reduced to oxides of nitrogen. So this is very important part. You can expect at least one question every time. CBSE has repeated this section, and many questions are there. You can check in previous year question paper of CBSE class 10, so you will get that. Okay, so hydrogen gas is not even when metals react with, see, in every case when metals react with acid, dilute acid, hydrogen gas is liberated. But in this case, in particular case, if the acid so is nitric acid, HNO3, so it does not let the liberation of hydrogen gas, because what is the reason? Because nitric acid is what? Strong oxidizing agent. So what is the function of oxidizing agent? Oxidizing agent, simple, it oxidize. Okay, it helps in oxidation. So oxidizing agent are the agent which help in what? Process of oxidation. And the which in this process, if you add this, suppose in this case, if you add magnesium plus HNO3, it will become what? Magnesium nitrate. Okay, magnesium nitrate will become, but H2 will be not be liberated. Why? Because see, the H2 so liberated during that process will be reduced to oxides of nitrogen. So it can form NO2 or it can form NO. Both will be reduced. Okay, fine. So in this case, you can observe copper plus HNO3 is giving what? Copper nitrate plus H2O. Formation of water molecule take place and nitrogen dioxide is forming. Okay, so that is the reason there is no, there is, see in this example you cannot see the formation of H2 molecule. H2 molecule is missing out here. Why? Because the H2 so formed is what? Oxidized, and the water molecule is so formed. Okay, so moving on reaction of this metal with what? Salt solution. Okay, so a more reactive metal displaces less reactive metal from its salt solution, that is displacement reaction. We have already discussed in chapter 1. So magnesium displaces copper from copper sulfate solution. In this case, magnesium can displace this copper, magnesium can displace this copper, and so compound is magnesium sulfate is formed, and copper is what? Displaced. Zinc can displace copper from copper sulfate solution. So one point you have to remember in this type of equation is that this element should be what? More powerful than this element. Suppose in this case K plus Na2SO4. Now this potassium can displace sodium, but if this is the case, okay, if this is the case, then there is no reaction take place. Why no reaction? Because this sodium cannot displace potassium from its solution. Why? Because sodium is less reactive. So you have to remember that this element which is being added to the particular solution of the particular compound, this element should be what? It should be higher reactive than this thing. That means this first element should be reactive than the salt solution of the second element. Okay, so in this case, see, magnesium powder is added, and you can check what is the reaction. Blue copper sulfate solution is there, so reaction, pieces of copper is there, and the colorless magnesium sulfate solution is formed. Okay, so if I add magnesium solution, magnesium, so what is the reaction? So magnesium is added to what? Copper sulfate solution. So after few minutes, okay, after few minutes, then magnesium sulfate is formed and copper is what? Liberated. So you can observe magnesium sulfate color. So color of this compound, that is copper sulfate, has been changed, and the pieces of copper you can clearly see from the picture. Okay, so what happens if you dip iron nail to the blue sulfate of copper solution? So if you dip by iron, what? Iron displaces copper sulfate and iron sulfate is formed. So this is the case. Okay, fine. Moving on. So this is the reactivity series. Arranging of metals in the decreasing order of their reactivity is called reactivity series of metals. So potassium, sodium, calcium, magnesium, aluminum. So you can observe, you can see. So potassium is more reactive than sodium, sodium is more reactive than calcium. So they are most reactive elements, and reactivity decreasing down a group. Okay, so moving on. So how do metals and non-metals react? So this part is very important. Star. Okay, so metal, they lose electron and become positive ions, so they are called electropositive elements. So why? See, suppose atomic number of magnesium is 12, so it has 2 comma 8 comma 2 electron. So if it lose 2 electron, total number of proton is how much? 12. Total number of electron is how much? 12. So if it lose electron, the electron will be reduced to 10. That means it has 2 more positive charge. That's why we will write it as 2 plus. That means this 2 plus indicates that this magnesium ion has 2 electron, that is deficit. 2 electron is deficit in this Mg2 plus. So whatever reactivity Mg and Mg2 plus, which one is more reactive? This Mg2 plus is more reactive. Why this Mg2 plus is more reactive? Because this ion is already in requirement of these 2 electron, which is shortage in its case. Okay, so atomic number of sodium is 11 and its electron configuration 2 comma 8 comma 1. So let us consider this example. Okay, sodium and magnesium. So the atomic number of sodium is 11, the electron configuration is 2 comma, and it has 1 valence electron. So it has how many electron? 1 electron in this valence shell. So it releases 1 electron and forms a sodium ion, that is Na plus. Fine. So Mg is giving what? Mg2 plus 2 electron. So atomic number is 12. An is what? Atomic number. So EC, electronic configuration, EC is electron configuration. Okay, so non-metals, it gains what? Electrons and become negative ions, so they are called electronegative elements. So metals are electropositive elements, Non-metals are what? Electronegative elements. So atomic number of chlorine is 17. Its electron configuration is what? 2, 8, 7. It has 7 valence shells. 7 electron is valence shells. So it gains how many electron? 1 electron and forms chloride ion, that is Cl minus. So it is chloride or chlorine, you can say chlorine. So atomic number of chlorine is 17. So if you add 1 electron, if it gain 1 electron, it will become chloride ion, so which is the stable. Fine. So moving on. So this part is very important. So how sodium is formed, how this NaCl is formed. Okay, so first step, see, sodium has atomic number of 11, so it has 2, 8, 1. So last valence shell, it has only 1 electron. So chloride ion has how many electron in the valence shell? 1, 2, 3, 4, 5, 6, 7. So this 1 electron of sodium, it will chlorine not ions, chlorine will what? It will gain, this 1 electron. Why it will gain? Because chlorine is what? Electronegative elements, so it will gain the electron. So sodium will what? Sodium will lose the electron. So after losing electron, it has some what charge? It has positive charge. So you can see in the picture, it is positive charge. And now this is how NaCl is formed. So 1 electron it has gained, so NaCl is formed. So atomic number of sodium is 11. Its electronic configuration is 2, 8, 1. It has 1 valence electron. It loses 1 electron to form sodium plus ions. The atomic number of chlorine is 17. Its electron configuration is how much? 2, 8, 7. So it has how many electron? 7 valence electron. So it gains 1 electron to form chlorine ion. So it gains 1 electron to form chlorine ion. Then the attraction between sodium ion and chlorine ion result in the formation of sodium chloride molecule, that is NaCl. Okay. Similarly, you can see the formation of magnesium chloride out here. Okay. Okay. So ionic compounds, we also called this compound as electrovalent compounds. So ionic compounds are compounds formed by the transfer of electron from metal to a non-metal. So if there is a combination like metals plus non-metals, then you can see Na bond Cl. This bond is called ionic bond. And the compounds of form, you can call this as electrovalent compounds or ionic compounds. Okay, so this is very important point. If you observe the formation of compound between one metal and another non-metal, then you can say that particular compounds of form will be what? Ionic compound or electrovalent compound, and the bond between these two element is what? Ionic bond. Okay, so properties is very important. So they are formed by transfer of electrons and made of ions. They are crystalline solid. Okay, they have high melting and boiling point. They are soluble in water but insoluble in organic solvents like petrol, kerosene, etc. They conduct electricity in molten state or in solution. Okay, but remember, they cannot conduct electricity in solid state. Okay, fine. Moving on, occurrence of metals. So metal can be extracted from the earth core. So some metals like gold, silver, platinum, etc. are found in the free state in the earth core surface because they are least reactive. Most metals are formed as oxide, carbonate, sulfate, halides, etc. Okay, so like gold, this silver, platinum, they are found in free state in earth core. But because why they are found in free state? Because they are less reactive. They cannot react with oxygen, they cannot react with water. And most metals found as oxide because they are very reactive and they can combine with carbon to form carbonates. They can combine with sulfur to form sulfides. They can combine with halogen atoms, they form what? Halides. Okay, so that what is minerals? Now minerals are compounds or elements which occur naturally inside the earth crust. Okay, so what are minerals? Minerals are elements, or you can consider it as a compound. Okay, now what is ore? Ore is a mineral from which metals can be extracted profitably. Okay, profitably means that ore is extracted from the earth crust to extract what? Metals, or to extract metal ore. So what is gangue? Gangue is impurities. So in minerals you have two things: ore plus gangue particles. So ore is what? Ore is a metal part, it can be extracted from the earth crust, and gangue is what? That is impurity present in the ore like rock particles, sand particles, clay particles, etc. Okay, now how these metals are extracted from the ores? So metal are extracted from the ores on three steps. Okay, they are first concentration of ore, that is enrichment of the ore, and reduction up to the metal, and the refining, purification of the metal take place. So first one is, what is concentration of the ore? So it is the removal of gangue impurities to form ore by the different metals. So in concentration of ore, in this first step, what you will do, you will extract, you will first, you will select the minerals, you will select the minerals, and then after selecting the mineral, what you will do, you will just remove the, in mineral you have two parts, one is ore, another one is gangue. So just you will remove this gangue particle from the particular this mineral, and that process is called concentration of the ore. So it is what, it is the removal of gangue, that is impurities from ore, by different methods. So different methods can be used, that washing, floating process, different methods can be used. Okay, so this is the step. Okay, so if metals are high reactive, then electrolysis can be done. Okay, electrolysis of molten ore. So after passing electricity, you can get pure metal. So in this second case, metals of medium reactivity, you can what, carbonate ore, that is, and another one is sulfide ore. So in case of carbonate ore, calcination, process of calcination will take place, and in case of sulfide ore, process of roasting will take place. Okay, so in case of metals that have medium reactivity, your ore, particular ore, that is carbonate ore or sulfide ore, can be converted to oxide of metal. In case of carbonate ore, calcination process is used. In case of roasting, that means sulfide ore is used. So you might wonder, what do you mean by calcination? Calcination is a process of converting this carbonate ore to oxide of metal. Okay, and roasting is a process of converting sulfide ore to oxide of metal. So next, moving on, this oxide of metal will be reduced to metal, and then refining process will take place. Moving on, what are metals of low reactivity? So how metals are refined in this process? So first they are converted to sulfide ore, okay, and then roasting will take place, and then metals are refined later on. Okay, moving on. So this is a process, metal of extraction low in activity series. So just you can read this all. Okay, and extraction of metals in middle of the activity series, roasting and calcination, we have discussed that everything in detail. And thermite reaction, this is the important. What is the process? Some reactive metals like sodium, calcium, aluminum, etc. are used as a reducing agent to obtain metals from the oxide. Okay, like say for example manganese oxide, I am treating it with aluminum, and manganese will be liberated. Why? Because aluminum can react strongly with oxygen, and manganese will be what, liberated. So in this process, the reaction between metal oxide and aluminum is highly exothermic. Exothermic means what? Heat is what? Release. So it is a chemical reaction in which it is released, and it is released to the system, and the metals are obtained in the molten state. Such reaction is called thermite reaction. So what is thermite reaction? Thermite reaction is a reaction between metal oxide and a metal, and which is highly exothermic. And so this metal so obtained is in which state? Molten state. Molten state. Okay, the reaction between iron oxide and aluminum produces molten iron. The reaction is used to join rail tracks, broken machine, etc. So you can study. Okay, this is a thermite wells. So we have already discussed. So what is this? So the reaction between iron oxide, that is FeO, or you can say Fe2O3, ferrous oxide, ferric oxide. So if you treat this with Fe2O3 plus FeO, if you treat this with aluminum, so what you can observe? You can observe the formation of iron. Okay, iron, because aluminum oxide will be formed. So in this process, it is used to what? It is used to join rail tracks and broken machine parts. Okay, so in this picture you can clearly observe that this breaking break part of this iron rail leak is being joined using this thermite welds. Okay, so extraction of metals at the top of the activity series. So electrolytic reduction is taking place. Okay, so metal at the top of the activity series like potassium, sodium, calcium, aluminum, etc. cannot be obtained from their ores by simply heating or by heating with the reducing agent, because they are very highly reactive. So they are obtained by electrolytic reduction of their molten chlorides. So when electric current is passed through molten sodium chloride, sodium metal is deposited at the cathode and the chlorine gas is deposited at the anode. So you can see in the picture itself. Okay, so after that, concentration of ore, so refining will be there. So what is refining? Refining is the process of reducing or removing impurities from the metals to obtain pure metal. Okay, and the most common method of refining of metals is what? Electrolytic refining. So this, read it once. So this is very important. Okay, very important. So In this method, a block of impure metal is made to the anode, and the thin sheet of the pure metal is made to the cathode. The electrolytic is a salt solution of the metal to be purified. So in the electrolytic refining of copper, a block of impure copper is made to the anode, and the thin sheet of copper is made to the cathode. The electrolyte is acidified copper sulfate solution. When electric current is passed through the electrolyte, pure copper from an anode is deposited at the cathode, and the impurity settle down as a anode mode. So this is very important. This is what electrolytic refining. Read it once. It is very easy. Okay, so last one we have to discuss about corrosion. Corrosion is the damage caused to metals due to the reaction of metals with oxygen, moisture, carbon dioxide, etc. So what is the result? So it will form brown coating of rust over iron, and green coating of basic copper solution over copper, and black coating or silver sulfide over silver. Okay, to show that air and moisture are necessary for rusting of iron. So this is the activity. So study, and you can perform this activity at your home. Okay, so last one. So how to prevent this corrosion? So you can apply oil or grease, you can apply paint, you can do the galvanization. What is galvanization? Galvanization is a process of coating metals with zinc, and you can by tinning. Tinning is a process in which metals is coated with tin. Electroplating, okay, coating or less reactive metals like chromium, and by alloying, making alloys. What is alloy? Alloy is a homogeneous mixture. Homogeneous means homogeneous mixture of metal with other metals or non-metals. So steel, mixture of iron and carbon, steel, iron and copper, cobalt and nickel, brass, copper and zinc. So solder, lead, tin, used for welding, electrolyte, wire together. And this, if one of the metals in the alloy is mercury, it is called amalgam. So amalgam, remember amalgam, in amalgam, one metal is mercury. Mercury is mandatory. If you see one metal is mercury, then the particular alloy you can consider it as a what? Amalgam. Okay. So this is all about this chapter, that is metal and non-metals. So this is the theory portion, or whatever that you have to study for the examination. So in next video we'll deal about the questions and the pattern that will be asked in CBSE 2025, and keep studying. For more updates and videos, don't forget to subscribe and hit the notification bell. Thank you so much.